Hello children, we are doing class 12 chemistry, chapter 4 chemical kinetics, extra question 3. The reaction 2N2O gives 2N2 plus O2 is experimentally found to have a rate given as rate R equal to K into concentration of N2O, such a mechanism consistent with the data. So, for finding the mechanism of the reaction, first we'll write the given overall equation. So here 2N2O gives 2N2 plus O2. I'll write as given data. Next on rate law, they gave in the question rate R equal to K into concentration of N2O. These two data were given in the question. From these two given data, we'll identify the mechanism of reaction. So now we are writing the mechanism of reaction. In the mechanism of reaction, here you have to identify the concentration of the reactant in the rate law. Concentration of reactant is N2O actually, only one N2O. Since only one N2O is there in the rate law, so in the reactant side for the slow step, we'll write N2O as the reactant. That is the only reactant. Its power is 1. So coefficient of stoichiometric coefficient for N2O should be 1 only. Now N2O should give you what is the product in the overall reaction. N2 and O2. So N2O will split into N2 and the remaining product by product left was O. Now this is the slow step. And slow step is considered as the rate determining step. Now, in the overall reaction, you want one more N2O. Actually, coefficient of N2O is 2. So, one N2O in the slow step included according to the rate law. Now, here, one more N2O you want. So, one more N2O we are writing. And O alone is not there in the overall reaction. So, it should be cancelled. So, we'll write that one with the second equation plus O gives. What is the product needed? So, this is a fast reaction actually. Fast reaction. Now, what are the products needed here? Products needed are, one is N2 because already one N2 is there and remaining is O2. So, we'll check whether we'll get that product. Yes, we'll get one N2 and one O2 as the products, as two products. Now, once more we are confirming the overall reaction. So, when we'll add the equation N2O plus N2O, that will be 2N2O. That is the overall reaction. Overall reaction. So N2O plus N2O, that is 2N2O. O on the left side as well as on the right side, it will be cancelled. Now, here on the product side, 2N2 plus again one O2 will be left, which is matching with the overall reaction given in the question. So now mechanism of the reaction is over. Now we'll go to question number 2. Hello children, we are doing question number 2. The half-life period of a first order reaction in A is 2 minutes. How long will it take concentration of A to reach 25% of its initial concentration? So half-life period is the time in which the concentration of the reactant is reduced to half of its initial value. So we are writing for the first order reaction. T equal to 2.303 divided by K log initial concentration of A, that is A0, divided by final concentration of A, that is A. So this is the standard formula according to this one. Otherwise we'll write R0 by R as the standard formula for a first order reaction. Now, since the concentration was reduced to half actually, so initial concentration in the first case, so we'll write let the initial concentration of the reactant. Let the initial concentration of the reactant. Be A0, which is equal to A, I'll assume. Then final concentration, the final concentration for the half-life period, we are taking for half-life period. Final concentration of reactant. Final concentration of reactant. Final concentration of reactant will take, that will be equal to concentration of A, or that is equal to A minus X, which is equal to A by 2 I'll take, because half-life it is A by 2. So now we'll write T half. T half will be equal to half-life period. Half-life period T half equal to 2.303 divided by K log concentration of A0 divided by, that is the initial concentration, divided by final concentration, which is equal to 2.303 divided by K log initial concentration of A0 is A0 itself, final concentration is, that one I'll take as A and next one will be A by 2. When you will take the reciprocal, so A divided by A by 2, when you will take it will become A into 2 by A, which is equal to 2. That one I just wrote separately. So when you take the reciprocal, this 2 will go to the numerator. 2 will go to the numerator when you take the reciprocal. So it will be equal to 2.303 divided by K log 2A divided by A. So it is in the explained form, directly you can write 2 also. So this A and A will be cancelled, and A and A will be cancelled, it will become 2.303 divided by K log 2. Actually, T half value, 0.693 divided by K. So that one, from where we are getting 2.303 log 2. Here I just wrote in the explained form because for the next equation, we want to cancel this log 2. That is why we selected this formula. So this one is T half equal to equation number 1. Now they told you here how long will it take the concentration of A to reach 25% of the initial concentration. So in the second part we are doing for 75% completion. At that time 25% of initial concentration will be left out. So here, so to reach 25% of initial concentration, 75% of the reaction should be completed. Therefore, we'll write that one as time taken to complete 75% of the reaction. That will be T 75% will be equal to 2.303 divided by K log. So otherwise one time I'll write the final concentration. Initial concentration still remaining the same. Just I'll write the final concentration. Final concentration in the second case. Final concentration of the reactant. Final concentration of the reactant will be equal to, that is concentration of A equal to 25% of A. That is equal to 25 by 100 of into A. That is 1 by 4A. Or you can write A by 4. That is the final concentration. In the second case, to reach 25% of the initial concentration. So that one can be written as A minus X also, which is also equal to A minus X. So I'll write therefore final concentration of capital A equal to A minus X, which is equal to A by 4. I'll keep it as equation number 2. Now here we want to find out, this is the final concentration of the reactant when 75% of the reaction will be completed. That means 25% to reach 25%. That means here final concentration of the reactant is 25%. So A minus X, 25% of A, you wrote 1 by 4A, A by 4. Now we'll take again the time taken. So time T equal to 2.303 divided by K log concentration of A, initial concentration A 0 divided by final concentration A in the second case. One more thing was the half-life period was given 2 minutes. Later we'll substitute for that one. T half was 2 minutes. So it will be equal to T equal to T 75%. I'm writing T 75. T 75% equal to 2.303 divided by K log concentration of A0 we took a small letter A divided by concentration, final concentration we got as A by 4. When you take the reciprocal again, this 4 will go to numerator because of A divided by A by 4. We will take the multiplicative inverse 4 by A, so it will be 4. So this 4 will go to numerator and we will get 2.303 divided by K log 4. That is equal to 2.303 divided by K log 4 is 2 square. 4 is equal to 2 square. 2 into 2. That is 2 square. This one according to property of logarithm, log m raised to n equal to n log m. According to the property of logarithm, log m raised to n equal to n log m. So this 2 log 2 will write as T 75% equal to 2.303 divided by K 2 log 2 into 2 log 2. Now here we will divide the two equations. Equation number 3. And T half they gave in the question, T half was actually 2 minutes. So I'll write that one as T half. The previous case T half was 2 minutes. So that will be equal to 2 minutes. I'll write 2 minutes. T half was 2 minutes. So now we'll write 2 equal to. So that will be equation number 1. Now we'll divide equation number 3 by 1. Equation number 3 by 1. So when you divide T 75% divided by 2, we are dividing left hand sides, equal to 2.303, question number 3 is data, by K into 2 log 2 whole divided by T 75 by 2. Whole divided by. Now we'll write this equation number 1's RHS part. So 2.303 divided by K log 2. Now 2.303 divided by K and 2.303 divided by K will be cancelled. And log 2 also will be cancelled. So when you cancel this 2.303 by K in the numerator and denominator, and log 2, only term left out is, only number left out was only 2. Number left out was only 2. So this log 2 and log 2 will be cancelled, and 2.303 by K and 2.303 by K will be cancelled. So now answer in this case will be T 75% equal to percentage divided by 2 equal to 2. You cross multiply. So T 75% equal to 2 into 2, which is equal to 4 minutes. Therefore, time taken to reach the concentration of A to 25%. Therefore, time taken by A to reach 25%. Time taken by A to reach 25% of its initial concentration. That is T 75% equal to 4 minutes. That is the answer. So now we got the final answer. Thank you, children.